Hello everyone, I'm Iuliana. I'm working at NXP. I'm part of the Linux kernel BSP team. I'm working on Linux, mostly audio subsystem, Zephyr, and also sound open firmware. Today we're going to talk about how to integrate my proprietary code in Zephyr. And the agenda for today, it's the following. So we are going to talk about Zephyr structure to see where we want to integrate proprietary code and where we are allowed to do that, about the license of Zephyr, some information about the requirements of application development and how can we create an application, about out-of-tree device drivers. Next topic would be toolchains, a case study of sound open firmware and its integration with Zephyr, and at the end we're going to draw some conclusions. So let's see. Zephyr project is based on West tool. Zephyr folder, the last one here, it's the main manifest repository. It contains the source code of real-time or the Zephyr real-time operating system. The West .west folder contains the West configuration files. And when we initialize a Zephyr workspace, multiple folders are created. Like the bootloader there, it's associated with the bootloader used by Zephyr. That's typically MCU boot. We have modules. These are projects that Zephyr relies on. They bring functionality and features that are approved and endorsed by Zephyr Technical Steering Committee. There are multiple categories of modules, including but not limited to debugger integration, silicon vendor hardware abstraction layer, what else? File system, cryptographic libraries, inter-process communication libraries, and more. Optional modules are a subset of the modules above. These are not used by all applications from Zephyr. They are used by some of them, and they are brought in Zephyr based on the specific requirements of an application. So if you want to bring this optional module, you have to do a West config before doing West update. Update populates and fetches all these modules. And then we have tools, where we have different tools for testing. On the right side, we have some modules example that can be found in Zephyr project repository, like SDK-ng, where we have the Zephyr SDK, and which contains the toolchain and some development tools. The cross-tool-ng is used to build the toolchains. Docker image provides a Docker image for Zephyr development and testing. We have there some examples. CMSys DSP and CMSys NN are optimized library used for computation and neural network. OpenAMP, LibMetal are examples for inter-process communication. LittleFS, it's an example of a fail-safe file system designed for MCUs. And there are more, others. Now, the Zephyr repository we have there on the right, it's well organized to facilitate development. We have there a high-level overview of its structure. We have architecture-specific files in the Arch, board configuration files in boards, build files in CMake, driver code. In DTS, we have device tree files where we define non-discoverable hardware for specific boards. In kernel, we have architecture-independent kernel code. In lib, we have library code like the minimal standard C library. A lot of samples in Zephyr to demonstrate the features of Zephyr. In stock, we have system-on-chip files. In some manifest, we added there the optional modules, tests, a lot of tests. And in addition to all these folders here, we have configurations and build files like kconfig, CMake list, and the main manifest, that's the West YML. Now, about the license. So Zephyr is Apache 2.0 licensed. It's a permissive and easy to understand license. It's widely used in the world of IoT. But it also uses and imports some scripts or packages that are GPL v2. Also, very important, For Zephyr, it's very important to follow the developer certificate of origin process. That means that when you have a contribution, by adding your sign of buy on your patch, you agree with this DCO. And also each file, each source code file from Zephyr has an SPDX license identifier, which clearly states the license of that file. If we want to import code in Zephyr, which is not Apache 2.0, well, in this case, there are additional steps to be followed. Usually this code needs to be approved by a Zephyr Technical Steering Committee or even by the governing board. And this flowchart shows the process of this. I'm not going to enter into details, but there are a lot of steps to follow in order to be approved. Okay, let's see some prerequisites of creating an application, of application development. So usually the Arch support is mandatory to be in Zephyr. We also expect for the board or SOC or device tree to be there, but they can also be out of tree. In case they are out of tree, it's very important for the board and SOC to have the exact structure as in Zephyr. So on the right side, we have a board structure. There are multiple files that can be found there, but only the blue ones are important. So in the board YML, we add the name of the board, the SOCs and variants of that board. In kconfig, we specify settings that are specific for that particular board, settings like board's hardware layout, memory size, or some peripheral configurations. And for the DTS, we add their information regarding some SOCs, about the SOCs of the board, about connectors or other hardware components, like, I don't know, LEDs, buttons, or other connectors. So if we have an out-of-tree board or SOC or DTS, we can give that just as a CMake variables when building the application with West-build. Now, another important prerequisite it's to be followed is the build system of Zephyr, which is based on CMake, and this is application-centric. That means that it requires that the Zephyr-based application to initiate the build of Zephyr code. The application build controls the it initiates actually the building of Zephyr code, and it compiles them into one single binary file. The files in the application directory link Zephyr and any modules with the application itself. On the right there, we have a structure of an application. The most important files there are the CMake list. That's the file that is used to combine our application with the CMake build system from Zephyr. And it's also used to tell the build system what other files are used for our application. And of course, the C code, the source code, which can be found in the SRC folder. In order to integrate external codes, there are two main options. So we can integrate them directly in the Zephyr repository. That's by importing the source code into Zephyr. So, but here we have to follow some requirements from Zephyr. That is the license, the coding style, the static analysis. The second options will be to import parts of a whole third-party open source project into a separate repository and integrate it with Zephyr as a module. Okay, so modules, I've talked about a bit earlier. There are, modules are limited okay, actually let's take these three options of modules, and we'll see which one it's best for a particular case. So we have to pay attention which kind of modules we use and where do we integrate it. So if we want to add modules in the main manifest file, in the WES-YML, these are limited to modules, to projects that are used by Zephyr subsystem, like, I don't know, libraries, by a platform, by hardware abstraction, like hardware abstraction layer, where we have the drivers for a particular vendor, silicon vendor. We have tools that are used to build and test Zephyr components. Now, optional module, we can integrate optional module. This should be standalone projects that have no dependencies or on any other project from Zephyr, and they are added in a special YML file. And then we have the external modules. These are not in the manifest of Zephyr. They are out of tree, and we provide only documentation on how a user or developer can activate their functionality. Okay, now it's the main topic of our presentation on how can we create an application. But first, let's see what type of application can we do. So there are three main applications. We can, based on the location of our application, we can have repository application that's in a West workspace, and it's in Zephyr repository. Next we have a workspace. That means that it's outside of Zephyr repository, but in a Zephyr workspace. And the last one is a freestanding application. It's outside of our workspace. On the next few slides, I'm going to show you an application I've created, and we're going to move that application from repository to a freestanding application to see what changes we have to do for these cases. We're not going to talk about workspace because it's very similar with the first one, and there are not much. Actually, there are no changes to make. I will explain later what changes might be possible, but it's very similar with the first one. Okay, so I've created an application, a number crunching sample. It does some vector operation, fast Fourier transformation, and filtering. This application will be moved in and out of tree to see what changes. To demonstrate how to integrate proprietary code, I've used the Nature DSP library from Cadence, which is in an out-of-tree location because it has a proprietary license. And by default, this sample is using CMSIS DSP, which is in Zephyr as a module. Okay, this is the structure of my application. Important files are in SRC folder. So the main, we do the operations. In MathOps, I've created a common API for the two, for CMSIS DSP and Nature DSP. And the specific API is called in their specific wrapper. Okay, in order to link our application to Zephyr CMake build system and with the out-of-tree library, we need to have some specific CMake commands in CMake list file. So let's see. In the first part, we specify the source code and include directory. Now comes the interesting part. Next, we define an environmental variable. I called it lib location. And based on this, we select the backend. With the add subdirectory CMake command, we add the external location of our library. Using link libraries, we link with the external library, and we include directory. Now, on my external lib location, I have the library, I have the headers, and the CMake list file. In this CMake list, I'm just setting 3 variables. So lib location, lib name, and include directory. These are used on the application side, as you've seen earlier, to link with the library and to include directories. Now, we can make some changes. We can move the part of link library and include directory from the application in the external lib location, or as you can see in this example, or we can use a CMake variable rather than an environmental variable. Let's see what changes, why would you do those changes? Well, there's not much of a difference. Difference is in the build command. So when we build the application, I don't know if you pay attention, but this was a repository sample, repository application, because it was located in Zephyr repository. So to build it, we use West build, we give the name of our board and the path to the application. So in this case, if we use an environmental variable to set the location of our nature DSP library, we need to set it before building the application. Otherwise, the CMC's DSP backend will be used. If we use a CMake variable, we just pass it when building the application. With, as you can see here as the second example with -d lib location. Now, the second solution of how can we integrate our external code in Zephyr. This is the Zephyr way, I call it. That means that we are using the external module mechanism from Zephyr. For this, we need to add the Zephyr extra module CMake variable when building the application. This CMake variable, it's already used by by Zephyr CMake build system. So we just pass it when building the application. Now, in this case, our external lib location is seen as an external module. So to be an external module, we need to have in Zephyr a special structure. So we need to have this Zephyr folder in our external module with this module YML file. Here in the YML file, we need to specify the name of our external module, because this will be used when building the application. It refers to this sample, to this external module when building it. And also, next with CMake, we specify the location of our build file, our CMake list file. In our case, it's in the root folder of our external module. And next, we define a blob. Let's see what's a blob. Okay, so with this solution, we use binary blobs to build with our external lib location. So what is a binary blob? A binary blob, it's proprietary machine code and data built in a binary file, and its source code is not released under an open source initiative license. Zephyr can download and use the binary blobs via its built-in system mechanism, actually. And yeah, that's about it, actually, about binary blobs. But in order to use these binary blobs, we have to specify the blob section in modules YML with those entries there. So we have the path where the binary blob will be downloaded, relative to our external module. We have a SHA. This is used to verify that the binary blob is valid. We have the type. There are two types supported right now in Zephyr. Okay, the version, the license path is very important. We have to have a license for that binary blob. The binary blob, it usually has a proprietary license, and we need to have that. The URL, it's the location where the binary blob will be fetched from. Description, a human-readable description of that blob, and the doc URL contains the documentation about that binary blob. How can you use it, and how to enable its functionality. This binary blob, it's fetched using West blob command, and very important, this command only fetches the binary blob. So if you need any other accompanying code, like the headers, they are not brought with the binary blob, only that blob. So we need to have the headers, in our case, in the external module. Let's see what changes. So in the CMake list file, do you observe something? not much, I'm telling you. So we just include directory, and we link with our external library, which right now actually it's a blob. It's called a blob, but it's still that library. Now, on the application side, we are checking for the Zephyr extra module variable. If it's defined, okay, we're selecting the nature DSP backend. Otherwise, the CMSIS DSP will be used. Let's see what changes if we move our application from Zephyr outside of tree. It will be a freestanding application, if you remember. So actually, everything applies as before. Just the build commands will change a bit. If we are building from a Zephyr workspace, we use the west build command. We give the absolute path or the relative path to the application. And in Zephyr, we get the build folder. I was mentioning before that I will not talk about the workspace application, but while I'm here, I will tell you that it's not much of a difference, because if we have the application in another place, also in the Zephyr workspace, we just give that path to relative to our project, to our Zephyr workspace. So that's why I'm saying it's not much of a difference. Now, if we are building the application outside Zephyr workspace, we are going to use CMake and Ninja. This is a three-step process. We'll set the Zephyr location, we'll use CMake to get the build folder, and use Ninja to compile the code. So first, we need to set Zephyr base. This is an environmental variable where we set the location of our Zephyr workspace. This ensures that the CMake can automatically select a Zephyr installation to use for building our application. Second step will be to use CMake to generate the Ninja-based system build. And we get the build folder there in our application. In this case, now we have in the build, we have the Ninja build file and other generated build files. And finally, we use Ninja to compile the code, and we get our ELF in the build folder in the directory, in our application directory. Okay, another use case is a custom workspace. That means that for a custom workspace, we'll need to have a specific manifest. That means a specific West-YML for our application. So in this contains a description of Zephyr installation, including Git repository, and the necessary dependencies of our application. So this is an example of how our West-YML will look like for this particular sample. So we only need the CMSIS DSP, the Extensa HAL, and NXP HAL, and we are going to mention this using name allow list. And for the Zephyr repository, we're going to use main branch. So that's about it. Why should I bring all the dependencies from Zephyr if I need only these? So I'll create my own West-YML. Next, when building the application, after we initialize the workspace, we use West update to populate the workspace, so only the needed dependencies are brought there. And next we can build the application as before, West build and the application. And yeah, that's about it. That's about it about an application. We can also have out-of-tree device drivers. And I have there on the right source code of a proof of concept of an interrupt, interrupt controller for RQSteer. RQSteer is an interrupt controller on the DSP subsystem of i.MX 810+. We know its base address. We know the interrupt number. We use Zephyr API, interrupt API, to enable the interrupt and to register the handler. And what we do is just trigger an interrupt to test the ISR is called. And you can see here on the left that our interrupt is triggered. That's the console output. Of course, this device driver, this proof of concept device driver can be improved and can be enhanced to be as Zephyr, as a Zephyr device driver, we can take the interrupt number or the base address from DTS. We can interface it with the interrupt management subsystem from Zephyr. And also we can integrate it with the build infrastructure. Okay, next topic is toolchain. Zephyr SDK contains toolchains for each Zephyr supported architecture. It's recommended to be used, and in some condition this is required, like in continuous integration. But you can also use some custom toolchains. For that, you need to define two environmental variables, Zephyr toolchain variant, that's the toolchain name, and toolchain root, the path to the directory where we have the toolchain's CMake configuration file. We can set this environmental variable, or we can pass them directly when building our application with West Build or with CMake, as you can see here in these two examples. Next, we are going to talk about Sound Open Firmware and its integration with Zephyr. Okay, a little bit about Sound Open Firmware. It's an open source audio DSP firmware and SDK. Has its own repository, its own lifecycle, CI, tools, and everything. It's BSD3 closed licensed, but also has some device drivers that are BSD and or GPL. Sound Open Firmware started as a standalone project, no Zephyr relationship whatsoever. It was using Extensa OS and its own device drivers. So later on, Sound Open Firmware technical steering committee decided to switch from Extensa OS to Zephyr. Once the Extensa architecture was added in Zephyr, we only had to add the board support. This is something I've done 3 years ago. I've added the support for the audio DSP subsystem on i.MX8 family, and I ported to hardware model 2 a few months back. And at that point, Sound Open Firmware was an out-of-tree application that was using only the Zephyr kernel API. The platform drivers were still in SOF, like my proof of concept device driver I've showed you earlier. Now we are porting the platform driver from SOF to Zephyr. So Sound Open Firmware will use not just the kernel API, but also the device drivers API from Zephyr. And also Sound Open Firmware was accepted as an optional Zephyr module. So I've showed you this because you can start from a standalone application, which is not a small application, it's a firmware, and you can port it to Zephyr or use some parts of Zephyr. So, okay, let's make a summary now. Zephyr build system is very powerful. You can do the same thing in multiple ways. You can create an application in and out of tree. You can link it with an external library using external modules or not. You can use binary blobs for an external library or not. You can also have device drivers that are out of tree, but you can also have SOC or board or device trees. So there are extensive documentation and samples, including mine in Zephyr, as a starting point that can be used as a starting point. Just you need to pay attention to the license, as in any other project. So thank you.
Okay, we have some time for questions, if anybody has any questions.
Hi, just one question about this out-of-tree build. As I understand, we still need to modify Zephyr itself, to modify with some modules YAML to have this downloading working, right? Or I missed something?
That module's YML, you add it in your external module. You don't have to modify anything from Zephyr source code. You have it in your external module, you put it there, and you modify it as you want. Well, you have to follow some rules for that, but you're not modifying source code in Zephyr or any other configuration file. It's in your external code.
Okay, thanks.
module actually.
Okay. Any more?
So do you have it on the roadmap to convert the sound open firmware drivers over to Zephyr? When's that going to happen?
Well, it's ongoing. This is ongoing. We already done for some of them, and I think we have 1 or 2 PRs open right now. But it's working pretty well. It will be done. It will be finished soon.
Okay. Any more questions? I think that's it then. Thank you, Iuliana.
Thank you.